Hey, shall I start, Joanna? Are we okay? So, good evening, everyone, wherever you are coming from tonight. My name is Dominique Marshall from the Department of History at Carleton, and I am the chair of the Shannon Endowment, which has allowed us to run this series over more than 20 years at Carleton University in the Department of History. This time around, we have paired with the Department of Geography and Environmental Studies, and we would like to thank them as well. We are organizing this virtual meeting from Ottawa, Canada, in the unceded land of the Anishinaabe nation, whose tradition of curating and honoring the past continue to inspire all of us in the region. We would like briefly to thank the donor, Lois Long, who passed away a few years ago and whose generous donation, which we owe to her love of local history, social history, and Canadian history, has helped bring people from far and wide to speak to our place. Her money is also used regularly to pay for the travel of many of our graduate students in further and further places. The series, it's the third of 4 lectures on climate history, has been convened by my colleague Joanna Dean, herself a historian of climate, also of trees and animals. And she is, as she is convening this, running a seminar, a 40-year-long seminar with students of our department who are also attending. Up to you, Joanna.
Hi, welcome everybody. I'm very, very pleased to be able to introduce Dagomar Degroot, the third speaker in this series on climate history. Dr. Degroot is a fellow Canadian. He received his PhD at York University in Toronto and is speaking to us from Georgetown University in Washington, D.C., where he teaches environmental history. He'll be describing the emergence of a new interdisciplinary field, climate history. He's a leader in this field. In fact, I think we can credit him with shaping it as founder of the popular website historicalclimatology.com, as co-founder of the Climate History Network, which connects scholars who reconstruct past climate changes, as well as through his podcast Climate History and his numerous popular and scholarly publications. His first 2018 book, The Frigid Golden Age, Climate Change, the Little Ice Age, and the Dutch Republic, was named by the Financial Times as one of the 10 best history books of the year. In it, Degroot explains how the Dutch Republic prospered in a prolonged cold period, the Little Ice Age, one that destabilized other nations. And in contrast to a literature too often focused upon dire predictions of collapse, his book offers lessons in resilience and adaptation. He will be developing this argument as a lead editor with Jara McNeil and Amy Hessel of the Oxford Book of Resilience in Climate History. The intent of the collection is to explore the ways by which populations have endured climate change in the past, and so to offer pathways to inform present-day policymaking and activism. He is now leaving terrestrial environments to work on the history of the solar system, with a book tentatively titled Ripples in the Cosmic Ocean Towards an Environmental History of the Solar System. For this evening, however, he will be staying here on Earth and offering some hope for a resilient future. Before I let him start, please note that we've had a lot of interest in this talk, and so questions will have to be posted on the Q&A tab at the bottom of your Zoom screen. We'll take them all up at the end of the talk. Now, over to Dr. Degroot. Thank you so much for joining us.
Well, thank you so much. Let me start my slideshow here. There we go. Can you see that? Okay. Oh, I have to go back here. There we are. Okay, so I'd like to begin by thanking Joanna, not only for that wonderful introduction, but also for inviting me to join you. I'd like to thank Dominique for the opportunity, Angelique and Harris for also making it possible. And it's also just want to say it's such a wonderful pleasure to be sandwiched in between Ruth, who comes after me, and Alan, who was my postdoctoral advisor at Western. I can't think of a better crowd to be part of. I also like to acknowledge that my work with the Climate History Network and historicalclimatology.com has really been a team effort. And also with the podcast, the Climate History Network, I built that with Sam White and another wonderful group of graduate students. I co-host Climate History, our podcast, with Emma Moswild. And on all fronts, I have been slowed by my wonderful children. So the historicalclimatology.com, I got to update that. And this is a good reminder that I need to do that. So anyway, thank you so much for this opportunity. And I wish I could do it in person, but I'm very grateful to have the opportunity to do it here in Washington, DC, where I can see the spires of Georgetown around me, and beyond that, the twinkling lights of the National Mall. I want to talk to you tonight about the field that I call the history of climate and society, and more specifically about how that field and how teams that I am leading are beginning to explore resilience and adaptation, the capacity for populations to cope with, and in some cases thrive in spite or even because of past climatic changes caused by natural forces. Now, many of you will have seen maps like this one. This is what we call a climate reconstruction. It shows us how temperatures around the world have changed since the late 19th century. And in these reconstructions, cooler colors are usually represented using, well, cooler temperatures represented using bluer colors, and warmer temperatures using redder colors. And as you can see, of course, the Earth has warmed dramatically, especially since 1980, so that it is now over 1 degree Celsius hotter than the late 19th century, which is often called the pre-industrial average. Now, here's another way of representing climate change over this period. As you can see, more than 1 degree Celsius hotter now since the late 19th century. But you may be wondering if you've ever seen reconstructions like this one and you don't have a background in climate science. Why these reconstructions only go back to 1880? And maybe you've already heard from Alan, that's because this is when weather stations were scattered around enough of the globe that meteorological instruments could begin to give us an impression of global temperatures. But you may still be wondering what happened before 1880? What happened before the instrumental period? And this is a really important question because we can't gain a sense of how anomalous present-day warming really is without gaining a long-term picture, without understanding the baseline against which the warming is happening. And it really would help for us to know how climates have changed in the past, because that would help us predict how local and regional ecosystems, environments might respond to today's warming. We might be a lot calmer about today's warming if we knew that it's been this warm before. So how do we go back before 1880? Well, a group of scientists called paleoscientists can answer that question by using so-called paleoclimatic proxy sources to substitute, to stand in for reconstructions combined for data that we get using instrumental sources like thermometers. Paleoclimatic proxy sources are aspects of the natural world that responded to past climate changes in ways that are still embedded within their composition. And if we very carefully study their composition, we can gain an indirect and imperfect record of how climate has changed. This is now a massive effort. This is a map that we just published a few months ago. And by we, I mean Kevin Anchikaitis, a paleoclimatologist, created this map for a team that I led. We just published it in the journal Environmental Research Letters. And it shows efforts to exhume 8 common types of paleoclimatic proxy sources using just National Oceanic and Atmospheric Administration funding. So you can see just the magnitude of this effort, which of course responds to the urgency of the need to figure out how climate has changed before the period covered by instrumental sources. Now, it can be difficult to know how these proxy sources actually work. So let's zoom in on just one of them, ice cores. You can think of the ice sheets of the Earth as natural archives or archives of nature. And that's because they formed gradually over time. And they're not permanent aspects of the Earth. The ice sheet on Greenland is just about 3 million years old, and the ice sheet on Antarctica is significantly older than that. But that means that as you drill into these ice sheets, you're actually going backwards in time. You can gain cylinders, you can zoom cylinders that look like this. Those are ice cores. You can see a paleoclimatologist doing that on the left here. And if you zoom in on these ice cores, you'll notice a series of layers. And those layers tell us how much it precipitated over units of time at the poles. We can actually gain annual resolution now. So that means that we can learn how much it precipitated, how much it snowed by year by year at the poles. Now that's useful, but these ice cores contain something even more interesting. And that's because when the Earth is hot, heavier isotopes, an isotope is just an atom with more or less neutrons. So heavier isotopes will evaporate from the oceans and eventually precipitate at the poles. More of these heavy isotopes will then enter the layers in the ice core. And that means that we can carefully measure the ratio of heavy to light isotopes in these layers, in these ice cores, to gain an impression, to gain an understanding of how warm or cold the Earth was thousands of years, even millions of years into the past. More importantly still, the ice cores contain tiny little trapped bubbles of air. If we're very careful, we can sample those bubbles and use them like little time capsules. And the bubbles will tell us the atmospheric composition of the Earth, again, going potentially millions of years backwards into time. That is how we can create graphs like the one up top here, which shows atmospheric carbon dioxide levels over the last 800,000 years. Carbon dioxide is the most important greenhouse gas, the most important warming gas, because it lingers longest in the atmosphere. And so as you can see here from this graph, carbon dioxide concentrations fluctuated pretty significantly over 800,000 years or so, responding to glacial and interglacial periods, what we might call ice ages, and the warmer periods that separated them, all the way up until pretty much the present, when they've shot upwards. And these ice cores therefore tell us that the composition of the atmosphere, thanks to human activity, has no precedent in the roughly 300,000 year history of our species. That's a very important finding. We are living in a completely transformed artificial atmosphere. Now we can also use ice cores and other proxy sources then to create reconstructions like the one at the bottom. This one we also just published. And I think it's unique. It actually shows how global temperatures have changed over the history of our species, which again goes back at least 300,000 years. Now, the graph is a little bit tricky. It zooms in by about an order of magnitude as you move from left to right, and then another order of magnitude. So the first half of the graph shows temperature changes over hundreds of thousands of years. And then the middle section of the graph shows just 20,000 years of change. And then the rightmost little section of the graph shows the last 2,000 years. Now, the first thing that pops out, of course, is the magnitude of climatic changes over the Pleistocene, the geological epoch defined by ice ages and interglacials. Right? So these were massive, massive climate changes. Then we have the warming that ended the last glacial maximum, the last ice age, and began the Holocene geological epoch, which is really an interglacial that's defined by relative climatic stability, globally at least. And some have argued, controversially, that everything we've built over the last 10,000 years, that agriculture in particular, owes a lot to this climatic stability. Now you'll see there's a little blip there towards the end, right? And that is, of course, rapid global warming, which is a lot worse than it looks on this graph because it is happening so fast. Remember, that graph is zooming in. Even so, even in this graph, we can see that global warming is pushing us to a climate that has no precedent, to a climate that is hotter than anything human beings have faced. And we are We have warmed the Earth now by about 1 degree Celsius, and we expect another 1 to 2 degrees Celsius, most likely by the end of this century. It depends a lot, of course, on the quantity of greenhouse gases we will release in the coming decades. So there's very significant changes historically that the paleoclimatic record reveals to us, but it also gives us a sense of just how dramatically we are changing the climate today. But it doesn't give us a perfect sense of climate change. It doesn't tell us as much about some seasons, for example. As you'll remember from that map, it doesn't give us coverage of the whole Earth, just parts of the Earth. And it doesn't tell us all that much about certain kinds of climate change. It gives us an only indirect record, for example, of changes in atmospheric circulation, how winds move across the Earth. To gain a clearer sense of recent climate changes, we can consult the archives of societies, which are just things made by human beings that either tell us directly what weather was like in the past, or that tell us how human activities, or that tell us about human activities that must have been quite profoundly and directly influenced by weather, such as the date of the harvest in different regions, or the use of harbors that might have been frozen in cold winters, but not in warm winters. We can exhume many sources in the in historical climatology as well. On the left here, you can see a representation of different records accumulated across China using the REACHES project, or with the REACHES project. And here, what historical climatologists will do is identify qualitative accounts of weather and try to quantify them in simple ordinal scales, which they will then calibrate with instrumental records of climate change in a period of overlap between the archives of societies and the period covered by instrumental records. It gets a little bit technical, and it's a bit of a process, but it has resulted in a very rich record of climatic changes that otherwise, or manifestations of climatic changes that we otherwise just couldn't know using the archives of nature. I think this image also gives an impression of just how many sources there are. Each dot in this map is an individual weather record kept by sailors on ships between 1750 and 1850. There are hundreds of thousands of them, and together they give us richly detailed information about wind direction and velocity, which otherwise we'd have a great deal of difficulty reconstructing. So together, the archives of nature and the archives of society allow us to create reconstructions like this one. This shows temperatures across the Northern Hemisphere over the last 2,000 years. Here again, the first thing that pops out to me is just the magnitude of recent warming, right? Which has certainly no precedent over the last 2,000 years. But for a historian or an archaeologist or somebody who studies the past, what's also interesting is very real variability even before the onset of industrialization. And this is variability created primarily by volcanic eruptions, or perhaps to some extent by changes in solar output, changes in the amount of solar activity and solar radiation that reaches the Earth. And there may be some other factors at work as well. You'll see in the 6th century CE, a series of dark blue lines. This is what's sometimes called the late antique Little Ice Age. Just how big this was, how big of a deal this was, still very controversial. But then also you'll see another band of blue lines representing cooler temperatures in the 13th century. And this represents the onset of what's called the Little Ice Age proper. A Little Ice Age was a period in which temperatures across the Northern Hemisphere dropped by a few tenths of a degree Celsius, more than that in some regions, and much more than that in some years. And it lasted with interruptions all the way through the 19th century. Now, I do want to emphasize, because the rest of this talk is going to be mostly about the Little Ice Age, this is a period that in magnitude is much smaller than recent warming. right? We're talking globally again about a few tenths of a degree Celsius, recent warming, well, more than 1 degree Celsius. Anyway, reconstructions developed by historical climatologists and paleoclimatologists have enabled the field that we call the history of climate and society. And this field is all about the thoroughly inter and multi and transdisciplinary study of responses by human populations to climatic changes, to climatic variability, to climatic anomalies. This just shows a smattering of recent books written by historians, most of which concern the Little Ice Age, but this is the tip of, of a very big iceberg. There are thousands and thousands of publications written in the field by scholars in many different disciplines, and that number is increasing. Sometimes it feels like exponentially from year to year. It is not a new discipline. It goes back about a century or so, but at least in history, I think it is newer. It was refined in the 60s and 70s, and I believe that just in the last 10 or 20 years, it's kind of entered the mainstream of the historical profession, maybe just the last 10 years, I would say. This is a field that has focused a great deal on stories of disaster, and its most influential studies concern the collapse of past societies, where collapse is defined in many different ways, but often as the rapid disintegration of social economic complexity, the replacement of political elites, or perhaps just the elimination of political elites, and in most cases, a rapid decline in population. Now, actually, whether collapse even occurred is controversial. There will be many scholars who argue that collapse is not really a thing, that societies don't suddenly disintegrate like this. Nevertheless, it has been a focus of the history of climate and society. Influential publications argue that the collapse of pastoral settlements across the Sahara, as the Sahara turned from a savanna to desert, led to a massive wave of migration that culminated in the formation of ancient Egypt, and that ancient Egyptian dynasties fell apart because of long-lasting so-called mega drought. Controversially, scholars have argued that the Western Roman Empire collapsed or disintegrated as a result, partly, of a drying and cooling trend that reached its height in the late antique Little Ice Age and reduced agricultural yields across the Western Roman Empire, then rendered populations more vulnerable to epidemic disease. I should emphasize that this is a controversial point. Scholars in my field have for over a century explored the disappearance of Viking or Norse settlements in southwestern Greenland, which coincided with the onset there of the Little Ice Age. And the story used to be that the Norse brought with them inflexible subsistence strategies from Scandinavia, which could not cope with the onset of climatic cooling. Now things seem much, much more complicated than that, and increased climatic variability, then cooling was just one factor among many that did in the Vikings of Greenland, at least in most recent studies. But this is still an ongoing area of active debate and scholarship, now again for over a century. Perhaps the most influential account of collapse in the field concerns the disappearance of classical Mayan city-states, or by disappearance, I really mean the apparent abandonment of city-states in the Yucatan Peninsula as a result of drought, catastrophic and long-lasting drought. And although here too, the picture is much more complicated in recent scholarship than it once seemed to be, still the underlying story is one of decline and disaster. Now, a scholarship that focuses on crisis can be largely qualitative in nature, and this kind of scholarship is pursued primarily by historians. Jeffrey Parker, for example, and still, I guess we can call it a relatively recent book, Global Crisis, has argued that population societies around the world all succumbed to disaster during the early to mid 17th century, when he claims the little ice age reached its coolest point. And he uses qualitative means to identify the role of weather in bringing about harvest failures across much of the earth. You'll note that the Dutch Republic, the precursor state to the present-day Netherlands here in that map of Europe, seems also to have suffered from disaster in this period. Or scholars may use quantitative means, and these are actually, I would argue, the most influential publications in the field, at least in recent years. To do this, you'll take a climate reconstruction with a certain resolution. Let's say it tells you about annual precipitation in central China, and then you'll try to quantify some sort of social trend. Let's say violence by looking at the annual number of wars, again, in central China. And you'll line up the graphs and you'll look for statistically significant correlations between precipitation and war. If you found them, you might argue that the climate variable or the precipitation variable controls the violence variable, which would mean that climate change causes war. This is a kind of methodology that I think historians are not exactly comfortable with, but it has been refined and refined again using different statistical tools like a superposed epoch analysis and recent studies. So there are these very different ways of trying to understand causation, trying to understand the role of climate in human history. And again, stretching back thousands of years. But many of them have in common that they focus on disaster and collapse. This is a graph that shows publications written only by historians, only about Europe, only about the Little Ice Age in the last 20 odd years. So a very narrow sliver of this field. I think it gives an impression of how quickly the field is growing, but also just how many articles, how many publications there are now in this field. This is, you know, this little sliver is 175 publications or so. But it shows that the rate of increase is driven by scholarship on collapse. Right? There's more and more, and disaster, more and more studies that focus on things going very wrong for people. Okay? And many of these different kinds of scholarships also use some of the same models and theories for understanding the influence of climate change on human beings. One that's very focused on subsistence crises, subsistence failures, and their destabilizing impacts. Now, this is a little bit tricky, I think, for HCS scholars to grapple with, because of course, over the long run, human populations have climbed very, very dramatically. And that was the case even before the onset of industrialization, when of course populations really skyrocketed in a vertical line. If we argue that climate change was important in shaping human history, which many HCS scholars will argue, then we have to grapple with the reality that, you know, at least for most societies, most populations, the past was distinguished by growth rather than decline. So how do we account for that? Of course, this is a bit of a, I should acknowledge, a bit of a simplification, but there's a good example embedded here in this graph. Jeffrey Parker argues that the world's population declined by 1/3 in the 17th century as a result of climate change. And of course, this graph reveals that, well, that's a little sketchy. I'll put it that way. So it's to critique the field, I think, hopefully constructively, to explore why HCS scholars have been so focused on a particular story, and to suggest that we ought to think about more diverse stories, that I gathered a team of leading scholars all around the world, paleoclimatologists, archaeologists, historians, geographers, and so scholars in many different disciplines, to write an article that was published in the journal Nature a couple of years ago. And again, this article argued that there are some systematic biases that have entered our field, some systematic problems, which I won't get into now. It proposes a new kind of research framework by which the field can be more constructively pursued. But then it also applies that framework to a whole bunch of case studies. that all seem to suggest that at least some populations thrived amid vast climatic changes, and tries to explain how they managed to do that. This publication received quite a bit of press attention, I would say particularly in the non-English media, although I think this article in Grist does a pretty good job of summarizing it. And I was asked by the UN Development Program to write up some policy recommendations on the basis of this article for their most recent development report. That's because we found in the article distinct pathways that populations could follow, different populations could follow in order to be resilient or adaptive in the face of climate change. And this is a little bit tricky because the terms resilience and adaptation, first of all, are controversial today, but second of all, have changed over time, partly by responding to controversy. Here, what we decided to do is use the IPCC definitions of the terms, but to use them because we feel like they presented an accessible way of trying to grapple with and explain how populations coped with climate change. And it was very important for us to be accessible, to reach a wide audience. We therefore use the IPCC definition of resilience, which defines it as the ability of societies to cope with a hazardous event, trend, or disturbance, responding or reorganizing in ways that maintain their essential function, identity, and structure. And here, adaptation is a subset of resilience. It's a means of building resilience by adjusting to actual or expected climate and its effects in order to moderate harm or to exploit beneficial opportunities. Right? So with those definitions in mind, we found 5 different pathways, which we called exploiting new opportunities. So in some environments, climate change might actually increase the productivity or the usefulness of ecosystems, of environments for human populations. We found another pathway, which is having a resilient energy system. So a means of extracting energy that does not depend on the most important manifestations of climate in your region. It's not sensitive to it. Found another pathway that we call resources of trade and empire. So some populations might benefit from extracting resources from either other polities or the far-flung outskirts of empire, the periphery of empires. And that's because if extreme weather reduced the shortages of a particular commodity in one region, it might be produced by another region that you would have access to within an empire or within a dense commercial network. So just because an extreme weather event reduces the supply of a resource commodity in one area doesn't mean you're all out. Then we found another pathway that we called political and institutional adaptations. And this is when institutions or governments were able to respond to a climatic anomaly by implementing measures that made them more capable of coping with that anomaly if it happened again, like a very severe drought, for example. And then perhaps the most important pathway that we identify, we called migration and transformation, which referred to the ability of populations to simply move from environments that were no longer as productive for them, sometimes by fundamentally transforming themselves so that they could cope with new environments or radically different social, economic, and political circumstances. So those are 5 pathways we found, but I should really emphasize that to us, they were never intended to be comprehensive. We think there are other pathways, and certainly we're open to refining how we understand these pathways. And that's in part why we've created that Oxford University Press Handbook of Resilience to find other pathways and to better understand the 5 that we've already uncovered. Now, populations, of course, did not need to follow just one pathway. And certainly some communities in a population would follow one pathway and other communities another, right? So we shouldn't think of societies as being able to, well, as fitting societies into just one pathway, as though they're homogeneous entities. And I think in examples of that, we can find them in the Dutch Republic, which was the focus of, as Joanna pointed out, my first book. Here you can see a map of the Dutch Republic. On the left, the darker gray is the Republic. The rest is the Spanish Netherlands. So it's a very, very small state, a very watery state. And you'll see in capitals Holland, that's its largest province, where a large quantity of its population, I think 60% of its population lived. And when we talk about resilience in the Dutch Republic, we're really focused on the coastal cities of Holland and to a lesser extent Zeeland, which got extremely rich and populous and interconnected, and you might even say capitalist, industrialized during the 17th century, which is really unusual, at least it was for me when I approached the project, because the 17th century in the Northern Atlantic was the coldest century of the Little Ice Age. So it was a bit of a mystery to me when I approached this book, how the Dutch Republic could thrive when I thought every other population seemed to suffer in the 17th century. On the right, you can see a depiction of 16th century Amsterdam before it really started to expand a century later. Now we can talk about then exploiting opportunities. The Dutch Republic consisted of a number of provinces that broke free of the Spanish Empire, which was really the hegemon of 16th century Europe. And for the first 80 years of its existence, or of their existence together, these provinces had to resist Spanish efforts to take them back. And they did so in a period of unusually high precipitation. Precipitation in the Low Countries is variable on decadal and century timescale, but in the late 16th and early 17th century, it was generally, with some significant exceptions, quite high. That was particularly high during Spanish attempts to invade the Dutch Republic and besiege its cities. That's important because according to the prevailing way of fighting war, you had to dig trenches around cities in order to fully besiege them, which was extremely difficult to do, as you can imagine, in rainy, muddy weather. But also Dutch defenders developed means of deliberately inundating farmland in order to literally wash away besieging armies. And this was more effective when water levels were high in stormy, wet weather. So this higher precipitation really presented a beneficial opportunity for Dutch defenders. It helped them defend their land. And this is a map that we created for the Frigid Golden Age that represents battles. And I don't know if it's immediately visible from the map. It was a difficult one to make, but just about every battle that was fought in the early and most difficult part of the struggle against Spain was fought during cold, wet, or stormy weather conditions that were typical of the Little Ice Age in these Low Countries. Now we can think about resilient energy systems. Across most of the world, energy came from and was flowed through so-called organic economies. And it really was the product of human and animal muscles that were nourished using agricultural commodities and that then were primarily intended to produce agricultural commodities on a relatively small and inefficient scale. The Dutch Republic was beginning to exceed the limits of the so-called organic economy. There's been a long-standing debate about this. And it was doing that by exhuming large quantities of a semi-fossil fuel, peat, and then by complementing it later on in the 17th century and the early 18th century with increasing supplies of coal. It was also doing it by using wind power, and to some extent water power, as it was never used before for transportation and for agriculture, for drainage, for industry. So the Dutch Republic, to an unusual extent, depended on wind and peat for energy. neither wind nor peat was sensitive to changes in temperature, which is really the most important manifestation of the Little Ice Age in this part of the world. So resilient energy sources, the energy source for the Dutch Golden Age was not sensitive to changes in temperature. We can also talk then, of course, when you're talking about the Dutch Republic, and if you know anything about Dutch or early modern history, you'll know this. The Dutch Republic was maybe the most important commercial and trade power of its time. And it crafted an ever larger empire that extended across the Atlantic Ocean and all throughout the Indian Ocean. Dutch merchants controlled European supplies of grain. They controlled a triangle trade in the Atlantic and another trade of wealthy commodities from Asia in exchange for silver, spices in particular from Asia. But all of this meant that there was always stuff coming into the Dutch Republic, and a shortfall of a commodity in one region could be compensated for with commodities from another. Dutch merchants, by transporting grain, in fact, not only were able to alleviate high prices in the Dutch Republic, but also were able to exploit high prices elsewhere for lucrative profit when, for example, extreme weather ruined harvests elsewhere in Europe. So now we're talking about the resources of trade and empire and the resilience that creates. Dutch institutions were also adaptive in the face of extreme weather and cooling climate. Dutch brewers' guilds, for example, invented and maintained icebreakers in order to keep open vital lines of waterborne transport. The flow, for example, of fresh water into cities, which was most easily maintained with boats. And you can see at the top here an icebreaker. It's being pulled by horses on land, and it's breaking pieces of ice into blocks that could then be used in cellars to preserve food. So institutional adaptations to a colder climate in order to preserve the resilience of at least the brewers' guilds and Dutch cities. The bottom, you can see something even more unusual, an ice wagon, which is kind of a bizarre hybrid of a wagon and a boat. And it was designed to travel very, very quickly across the ice. In fact, at speeds that were totally without precedent at the time, about 80 kilometers an hour. It was not widely implemented. The design was to send messages quickly between military installations. But you can see a kind of inventiveness, an effort to grasp for solutions to a cold climate. Maybe the ultimate example of this are fire engines and fire hoses, which were developed in response to a series of urban fires in 1666 that followed from droughts, very profound drought, at least it followed in part from droughts in vulnerable wooden cities across Europe. Now, can we tie those droughts to the Little Ice Age? Maybe not, but certainly these are droughts that revealed how Dutch inventors responded to extreme weather. You can find more examples from my recent work on the Arctic and the Dutch whaling industry that emerged in the archipelago of Svalbard, roughly halfway between Norway and the North Pole, and the volcanic island of Jan Mayen in the 17th century. Early in the 17th century, small groups of Dutch whalers hunted a population of about up to 100,000 bowhead whales from small coastal encampments, where they would strip the whales of their blubber, boil the oil, and then ship the oil back to the Dutch Republic. Eventually, and for complex reasons that I don't have time to go into right now, the Dutch and other European whalers created large coastal encampments, even towns, at Svalbard and Jan Mayen. The largest was called Blubber Town. And they even attempted to colonize these towns year-round. But whaling was still a coastal activity, and it had a lot of trouble responding to renewed climatic cooling later in the 17th century that blocked much of the coast in Svalbard and Jan Mayen, even for much of the summer. And also it had a lot of trouble responding to what seemed to have been changes in whale culture, where the whales altered their migratory patterns in order to avoid the killing grounds off of Smerenberg and Jan Mayen. So the major Dutch whaling company, the Northern Company, collapsed, but it was replaced by individual whalers sailing in their own ships who pursued the whales in eventually unprecedented numbers. How? By designing new ships with hardened hulls and greased hulls, but also by learning how to actually strip blubber from the whales out at sea, and even to boil the blubber aboard their wooden sailing ships. That was a dangerous thing to do. Eventually, whalers simply stripped the blubber, got it aboard their ships, and brought it back home and refined it in the Dutch Republic, where it reached a purity that could never be reached in the Arctic. So again, these adaptations, and this time now intersecting with a kind of imperial extraction from the periphery. Now, the story of the Dutch whaling industry, I think, also begins to reveal the downsides of resilience and adaptation. Because resilience for the Dutch and for Dutch whalers, well, first of all, came at the expense of a lot of poor whalers who went up to the Arctic out of desperation, and whose skeletons still remain there, certainly enriched Dutch merchants and many of the elites in Dutch coastal cities. But of course, Dutch resilience and adaptation also resulted in vast destruction of sapient life in the deaths of bowhead whales, and the destruction of bowhead whale culture, and ultimately the death of some 100,000 bowhead whales, the transformation of the Arctic ecosystem. And to a much more extreme extent, similar depravities sustained Dutch resilience all around the world. The Dutch expansion into Asia, which ultimately greatly enriched the Dutch Republic, came with enormous violence against local populations. And the most egregious example of this, of course, is Dutch participation in the slave trade, where ultimately some 11 million Africans were transported to the Western Hemisphere. So resilience for Dutch coastal cities came at tremendous cost, eventually anyway, for the rest of the world. So just to sum up here, because I know I'm running out of time, I would say first that our field, the history of climate and societies, reveals that past populations were certainly vulnerable to climate change, right? But they were also, I think we're beginning to see that they were adaptive and resilient. And I think our work on resilience is emphasizing that resilience is not necessarily a virtue. We think so much now of building resilient and adaptive societies, but what if we're simply perpetuating unjust social, economic, and political systems? Right? What if the resilience of some populations, some groups within our societies, comes at the expense of other groups? So we have to think very carefully about what we want to create when we say that we're building a resilient society. I would emphasize also that the past is a foreign country. There are hard limits to what we can learn from the past, and there's even a danger of approaching the past in this way, approaching the past in order to learn lessons from it, right? This has been very controversial in the historical profession over the last few months. But still, I would say that examples of crisis and resilience in the past from very different populations to our own, in the face of very different climate changes than the ones we face, have much to teach us. And I think it's important that we try to learn these lessons, because we are, of course, facing potentially a catastrophe in our imminent future. Right? I like to show this graph. This is where we are, a little bit over 1 degree Celsius hotter than the late 19th century average. And the future is still very much in our hands. We can warm the Earth by 4 degrees Celsius or more, thereby fundamentally transforming the planet in a way that may be difficult for humanity to survive. Or we can limit warming to maybe 2 degrees Celsius, perhaps even 1.5 degrees Celsius. There are promising signs that we are beginning to move in that direction, but much more progress is needed quickly. In the meantime, we can consult the past in order to learn how to adapt to the changes we have inevitably set in motion. Thank you so much. I look forward to your questions.
Thank you, Dagomar. It was a very thought-provoking lecture. Because I teach climate history, I know just how hard it is to make it all as clear and straightforward as you did. So thank you. Anybody who has, we have a couple of questions, but they're not sort of discussion questions, they're for further information. So if anybody has any questions, please put them on the Q&A. Oh, here comes one already. So an anonymous attendee is asking, what are, in your views, the most exciting directions in climate history today?
That's a really great question. So one thing I'll flag right off the bat, and this is something that one of my graduate students at Georgetown is working on in part, which are climate histories that incorporate gendered histories of climate change. Believe it or not, maybe you do believe it, scholars working in climate history, which I define as a subset of the history of climate and society, have not really incorporated gender into their analysis at all. And yet there are all kinds of opportunities for doing that. It's not easy to do, but my student Emma, for example, is finding all of these tracks from Scotland that show how women played a key role in adapting to changes in harvest yields, changes in seasonality in the 18th century. So there are all kinds of ways of incorporating, I think, gender into climate history that really we're just beginning to scratch the surface. I would say also that I've been recently very fascinated by incorporating animal-human history. Joanna, you're much more of an expert in this than I am, but incorporating that kind of history into climate history. My work with bowhead whales have revealed to me that sometimes the animal decisions and animal cultures that shape how human beings interact with each other. Really, we're dealing with all kinds of different agents that are all sort of interacting in this jumbled mess. This is really fascinating. And again, I think very little has been written about that. I would say also indigenous climate histories. More and more is now being written about how indigenous populations weathered climate change. And I think this is critically important because scholars in my field, particularly archaeologists, Jared Diamond, who's not an archaeologist, but is perhaps the ultimate example, I've written about indigenous experiences of environmental and climate change as though indigenous polities were, first of all, isolated, right? And second of all, uniquely vulnerable to climate change. And that is exactly the opposite of what scholars are now finding. They're exposing the intricate links between indigenous polities, but also just how flexible and adaptive indigenous populations often were. I mean, in some cases more, many cases more than, for example, European societies in the face of the Little Ice Age. There's a book called Snowshoe Country that came out recently that does this brilliantly, I think, but so much more could be written. I could go on and on. You know, the histories of the oceans are really exciting to me as well. One of my fields is the history of climate change and conflict, which is very well covered. There's a huge literature, but I believe logistics and resource flows really need to be incorporated within that literature. I mean, there's just no end to what can be done here. And that's in part because the field has been so focused, I think, on a relatively narrow range of stories. And I think now we can diversify the field in fruitful ways. Anyway, I don't want to respond to that at too much length, but it's an exciting question for me.
Not too long at all. And that same person said, thank you for the talk as well. I'll go to a question from Brian Gordon. He says, I'm an archaeologist following Doggerland that connected the continent from Britain. in Dutch land reclamation, they are filling this void of who occupied this submerged world by finding artifacts. I'm assuming that will make more sense to you. I've never heard of Doggerland, but
Oh yeah, well, it's a fascinating story. As you probably know, and maybe some listeners will know, sea levels used to be massively lower than they are today, to an extent that's kind of hard to fathom today. But you could see those past climatic fluctuations, right? The glacial periods and just how cold it got, 6, maybe 7 degrees colder than the pre-industrial average. And you can only imagine what that did over thousands of years to sea levels, right? Exposing the whole lands, territories that are completely submerged today. You know, speculatively, this might even be where the legend of Atlantis comes from, right? The massive sort of inundation of vast tracts of land. And Doggerland is probably the best known example of this, where it used to be some very fertile land that was populated by hunter-gatherers. And gradually that land was worn away at the end of the last glacial maximum. But the real inundation, the big inundation, happened very suddenly. And I'm sure that Brian will be able to tell much more about it than I can. I taught it, I think, a couple of years ago, but well, one forgets until one has to teach again. But it's a fascinating story, and it exposes just how variable the Earth has been, right? And it also shows, I think, how important it is in this field to work in teams. You know, if I partner with an archaeologist and maybe a geneticist and a paleoclimatologist, I can range across tens of thousands of years. And the topics I can explore can be so much broader than I could do alone.
great, thank you. I have a question I wanted to ask you, so I'll take advantage of the opportunity, and that is to ask, why is it that collapse has been such an attractive narrative thread for so many years, and whether you've had any criticism of the focus on resilience, and whether that seemed to be in some way aiding a climate denialism or a minimization of climate. So sort of connected questions.
Yeah. So yes, let me begin with the collapse. I believe that it's been kind of maybe the dominant trope that's emerged from this field, right? Certainly one that enters into popular discourse most often, for a few different reasons. One of them is that scholars often approach the field and get into the field to try to explain something that seems at least partly mysterious, using existing causal explanations, right? And usually those mysterious things are particularly interesting because they're well documented, or there's a lot of evidence for them. And that means usually some kind of catastrophe, some kind of collapse. And so in trying to explain a disaster, they discovered that climate has changed. And sometimes they discover that climate change coincided with the disaster. And so there's, I think, a kind of systematic bias in how people are approaching the field. Let's just say that nobody's ever, or very few people have ever approached the field to explain just an ordinary period in human history where nothing really big seemed to change, right? So that's the first thing I would say, and I think that's why there's a lot of scholarship that focuses on collapse in particular. I think, well, there's other reasons too that might be biasing the kinds of studies that are being done in the field. For example, an assumption that the most direct impact of climate change on human affairs is through agriculture, right? And there the effort is often to discern how climatic extremes influence agriculture. And as soon as you're focused on extremes, you're focused on agricultural declines, right? And so that then also, of course, perpetuates the stories of disaster. And then I think in popular discourse, I mean, well, there's a legitimate side to this, and I think a less legitimate side to this. The less legitimate side is that I think obviously our media wants clicks, right? And Even before there were clicks, there were subscriptions, and people are much more inclined to read about negative things, scary things, I think, in general. There's been lots of research that shows this, as opposed to happy stories, right? So I think that's part of it. But the other part of it is that we're all legitimately, very legitimately concerned about what the future has in store, right? And I think in that sense, it seems that stories of disaster have more to teach us. They might teach us how to avoid the disaster that our ancestors experienced. And of course, when you're talking about pre-industrial climate change, there's always the kind of sense that, well, where we might be headed in the future is worse than where we were in the past. So if it was this bad then, it will be worse in the future. So I think that's, why I sometimes hesitate to tell different stories, because I know that that's legitimate. Now, criticism, I've encountered a lot of criticism, always, for any kind of work that I do, especially on social media, I guess. And I think you have to be very careful with this kind of work, right? You do not want to give the impression that climate change is just something that populations can easily endure, which is why I always emphasize again and again that the climate changes of the last 2,000 years that were natural in origin, very different from the ones that we're setting in motion now. And in fact, some of the same people who told you about climate change in the past are the ones telling you about present day warming, right? So you better take them seriously. But then also, when we think about resilience, I think it's not just a happy story, right? It's a story that reveals some real risks in our efforts to build resilience and to adapt to climate change. And I think it's an important story partly because it has warnings for how we do that kind of work. Right? It shows us, for example, that we need to think very carefully about social economic equality as kind of a basic building block of building resilient societies. We can't just focus on seawalls or GMOs, right? We have to really kind of rethink how we organize society. This is kind of, utopian language. I tend to be a little bit more pragmatic in how I understand the issue sometimes, but I think that's really important. I think when it comes to policies like the Green New Deal here in the United States, for example, which is, many of you will know, is kind of an aspirational set of policies that are unlikely to be adopted, but serve as a kind of North Star for where we should go in the future, and the climate and parts of the climate community. I think our work on resilience in the past shows the basic validity of the approach embedded in the Green New Deal, which is whole of society, right? It really emphasizes on a very basic level the importance of building a more just and more equal society. So anyway, criticism, yes, I get it a lot. Some of it is justified.
And a couple of questions slipped in that I hadn't noticed, which is why I broke in. One from Libby Robin. There are wonderful Celtic myths of Doggerland between England and Denmark in today's terms. So myths and legends might have to be part of the climate histories of the future, exploring Indigenous ideas historically, if you like. So perhaps more a comment than a question there. But
first of all, I want to say hi to Libby. Hi, Libby. Libby is one of the great scholars in this field, as many of you will know. And second of all, I'll say that there's a whole kind of emerging discipline whose name I'm forgetting. It's very dumb. It's in a chapter of my forthcoming book on space. But there's a discipline that focuses on gleaning environmental data from ancient myths, and then also exploring kind of the environmental motivations for ancient myths, legends, and stories. But yeah, and the name of that discipline, I'm forgetting.
It'll come as soon as this is over. Libby actually had a second question that she popped in here, and she says the field is a very northern hemisphere one, which she would notice. What sorts of southern hemisphere connections, apart from the Antarctic ice cores, are there, given that humans came out of southern Africa originally, then to Australia, which interests me, she says.
So it depends on what part of the field you look at. if you think of the field as climate history, as undertaken by historians, then I think there's a gargantuan northern hemisphere bias. And there's a bunch of different reasons for that. One is that many of our tree rings come from higher latitudes, the tree rings that we use. Tree rings are a really important high precision source that tell us about changes in growing seasons, in particular temperature and precipitation, but they have a lot to tell us. Tree rings, very, very precise, but really you can only find them, you can only use them, at least until like very, very recently, in areas where there are growing seasons, right? Which means not the tropics, because trees grow continuously there. This is maybe, as far as I know, this is changing right now, that we can begin to get environmental and climate data from tree rings, even in the tropics. So there's a reason that's connected to the archives of nature, and the ones that we can use. And there's also, of course, a reason that 90% of the human population is in the northern hemisphere, so that's going to be a focus of a lot of this work. But then there are also, like real, I think, gaps in climate history that flow out of our desire to use documents, surviving texts. And I think they can be redressed by working in more interdisciplinary teams, because certainly archaeologists, geneticists, historical linguists are able to shed light, for example, on migration, for instance, in sub-Saharan Africa, Central Africa, and East Africa, are featured in our Nature article, for example, through the techniques of historical linguistics. So I think it's in working in consilient teams that we can begin to write much more comprehensive histories of how climate has shaped human affairs. Ruth obviously is going to be on in the next lecture here in the Shannon series, and Ruth will know a lot more about Australian climate history, certainly, than I do. So does Libby.
Okay, whole bunch of questions coming in here. Someone else commented on the skewing towards Western cultures and says it seems like a lot of Eastern and Indigenous climate cultural history has been left to the wayside. For example, there is rising evidence that South American populations were immense pre-contact, and their disappearance caused a shift in climate due to loss of population and cultural landscaping practices of what is now rainforest.
Yeah, so I would say, first of all, that the field has historically, and by historically I mean since the 1970s, when it was really reinvented as a serious discipline, focused on Western Europe and I would say Eastern China. And the reason for that is tied again to documentation, right? Where you can find plentiful documents from the, gain sort of dense archives of societies. I think that is really beginning to change now. So in our Oxford Handbook, we cover 6 continents, and we've got a lot of scholars writing chapters for each continent. That's possible now. And I want to really emphasize this, because the field really is global now. Maybe not as practiced by historians, although increasingly it is. There's lots of great work on Indian climate history, for example, written by historians that's come out just in the last 5 years. But also because, and I'm trying to encourage this, scholars in these different disciplines can now work together to develop what we call consilient climate histories, or histories of climate and society. So there's actually an awful lot of work on Central and South America written by archaeologists. This is one of the major themes in the field, how populations there were able to be flexible, resilient, adaptive. Some that had extensive hydraulic infrastructure were not, others that practiced sort of forest cultivation and management were. There's a lot of work that's being done specifically on this topic. On the topic of whether the depopulation, the great dying so-called, in the Americas triggered climatic cooling, as I understand it, and I've written quite a bit about this, it's still controversial. We're talking about changes in CO2 concentrations of just a few parts per million, at the very most 7 parts per million, as this dying was unfolding. And whether afforestation in the Americas was countered by deforestation elsewhere is still very much an open question. So I'm uncertain about that connection. I doubt it though.
Okay, I'm having a hard time choosing questions. I don't want to keep you here all night. One rather intriguing question, especially related to what I've been hearing from my students, is Gab McLaren asked, you mentioned that some people approach this field due to climate anxiety. I was wondering if you could speak to managing those anxieties while working on these topics.
Well, I have to admit, I have a tough time doing that. So I'll just begin by saying it's not easy for me. I do find that as I learn more about scholarship in the hard sciences, and I gain more connections to climatologists, I think I gain a more nuanced understanding of how the Earth is changing. That doesn't necessarily make me less anxious at all, but I see more reasons, I guess, for, and again, I kind of hesitate to use the word optimism, but perhaps less abject panic I otherwise might feel. I particularly find encouraging stories and encouraging narratives from how, well, the green economy is shifting at a speed that was kind of unimaginable a few years ago. Certainly 5 years ago, we were on course for the most extreme emission scenarios, which are called SSSP 5 or RCP 8.5, the most extreme scenarios where we release all the emissions we can into the atmosphere, warm the Earth by 4 degrees Celsius. And now, as a result of the plummeting cost of renewables, as a result of thousands of climate policies imposed globally, we are on track for something less extreme, less apocalyptic. Maybe 2 degrees Celsius of additional warming, maybe 1. That is still very much within reach. And I didn't expect to be here 5 years ago, when around the time my daughter was born. So I'm happy that we've sort of bent that curve a bit. We've got to bend it a lot more, but there is real progress now, that tangible progress that we can see. But the short answer is that the biggest difficulty of working in this field, I think by far, is the emotional toll it takes on you. And that's an emotional toll that I think is not easy for others to understand always. And certainly one that I have difficulty dealing with. So, yeah.
Interesting answers. Yeah. Maybe we could take a couple more. Are you good for a couple more questions? Sure. Dominique had one, and I was going to let her ask it herself if she wanted to unmute herself. There she goes.
Thank you for the privilege. I was just asking if, as you go through your work, you find that your field has had an impact on historians' understanding of time.
Of time? Well, that's a fascinating question. Has it had an impact on historians' understanding of time? Well, first, I would like to know what historians think outside of this field. Whether they think more about kind of the Brodelian sense of these different processes at work across different timescales as a result of HCS scholarship and I guess paleoclimatology. I don't know. And maybe this is actually something that's worth emphasizing. I think that the field has influenced the practice of historians in a couple ways. I think it's shown them to an extent unimaginable maybe 10 years ago, that the Earth is a sort of actant, that the Earth is volatile, it's changing, that natural forces play an important role in human history. So, okay, fine. I think it's shown them that there are these other archives that historians can consult that have important information in them, so that, you know, we might be able to write different stories about the past than we would using only the sources in which we have expertise. Okay, that's really fundamental. My colleague here just down the hall, John McNeil, has spoken about this in his AHA address, American Historical Association address. Fine. But actually, Dominique, I think you're pointing towards something very significant, which I think is that this field has not really transformed how historians, for example, understand causality. You know, like those are like the very basic understandings that historians have about how historical change happens. Not just, you know, adding another set of factors, but really just fundamentally how it transpires. I don't know if the field has reshaped that, but I also don't know how much, you know, how that comes to change anyway. You know, I think that's just a fascinating question that requires thought.
Thanks.
Dominique's known for difficult questions. So, Dagomar, you've answered a couple of the other questions in your answer with Dominique, and I think it's time to thank you and not keep. There are more questions, and we can share the question panel with you after, so you know what people, a number of very interesting comments made. Just having one last look. Very nice. Thank you. I have to go, but an amazing talk from one person who sums it up for all of us. Thank you. Thank you so much. We all learned a lot and really appreciate all of your different thoughts and knowledge, incredible knowledge on this subject. So there's no way of having a crowd clap, but maybe everybody could quietly clap on their own. And yeah, thank you, Dagmar, for coming.
I appreciate it. Thank you so much, Joanna. Thank you.
Bye.